Give me a point and make it interesting, not something boring.
Negative 7, 9.
Negative 7,
9.
9. Okay, so we have a point at negative 7 and 9. Somebody give me another point somewhere interesting. 17
and 2.
I'm going to make it negative. 17, negative 2. Okay? Okay, we have a second point. 17, negative 2. Okay. First thing we probably want to do is what?
Draw.
Great. Man, I was hoping you'd say that. Okay, draw it. Draw the sketch. So we've got a pretty big number here, 17. I'm going to do that one first so I can sort of establish my scaling. So I'm going to go way out here. I'll call this 17. I'm just going to drop down a little bit to indicate negative 2. So that sort of sets my scale, doesn't it? And then I'm going to plot now, using that kind of thinking, I'm going to plot negative 7, 9. Negative 7 is less than half of this. Negative 7 is going to be over to the left. And up 9 is going to be a little more than that up. Probably somewhere up in here. Okay, now we're looking for what? We're looking for the line. Here's a quick summary of what the problem is. We're looking for the line that goes through these 2 points, the equation of the line. We drew the sketch of the 2 points, now what? Based on what we talked about last session? Draw it. Next. Good old Pythagoras, right? Okay, Pythagoras helping us out. Right triangle here. What's the rise? 9 dropping down to negative 2? 11. And we're probably going to assign what to that? Because the line's falling to the right.
Negative.
Imagine the gopher in the last session drilling the hole down, negative 11. And we're going to run positive x. How much? Arithmetic. 17 and 7, 24. Okay, positive, right? So we have our slope is negative 11/24. Is that reducible? No. Prime number 11 does not go into 24. There's our slope. Okay, I want the equation of the line. We got the slope. Feeling good, got the slope. Okay, we could use the formula, but why don't we jump to, which would you prefer? The point slope formula or the mx plus b? You can use either one. Your choice. There's always more than one way to do a math problem. Everybody hear that? There's always more than one way to do a math problem. How many of you get nervous because you think there's only one way to do it? Frequently that's the case, and then you go, oh man, I don't remember that one way to do it. I'm stuck. Can't figure it out. There's always multiple paths to get to the answer. So you could use either one of these. I'm going to grab this second one, use it, because I know the slope. So I have y equals my slope of negative 11/24 x plus an unknown value of b. Oh man. Ideas? I'm stuck. How do I get to finish the equation? Because I got to figure out what that b value is. And we, also, what do we know about this b value based on this sketch?
It's positive.
It's positive and probably a little less than, better be a little less than 9, right? So we have our brain based on this picture. We know where our answer better be when we get done. Okay, so I got that unknown value of b right here, this height. So how do I find that? Pick a point. Doesn't this represent x and this represents y? So why not now assign values of one of the points that we know is on that line? We could use either one. I'm going to go ahead and use the 17, negative 2. So using 17, negative 2, and drop them in there. Be careful. Watch your arithmetic. -2 equals -11/24, 17 times 17 plus the b. Don't we feel a little better now? Because the only unknown here is this thing called b. Okay, so we have some arithmetic to do here. What I would probably do is move this negative number over to the other side. So my b value is going to be a -2, and I'm going to be adding to it, once I move that to the other side, 11 times 17 over the 24. None of that reduces. And at that point, you could use your calculator, but I would, well, actually, if you did use your calculator, go ahead, somebody. And I'd like to see what it is as a fraction.
187 over 24.
Excuse me?
187 over 24.
Okay. 187 over 24. We get that, and I don't think that's reducible. And that value, think about it. Imagine 24 going up into 187. Go ahead and get it as a decimal.
7.79.
Approximately 7.79. Okay? So if we want the exact value on our sketch up here, then it's going to be a 0, 187 over 24. Sorry for the messy writing. Notice what I talked about the other day is exact. I'm using equal sign, and then approximately once I use my calculator, and notice that the approximate value does fit in what we expect, something less than 9, because of the height here being less than 9.
Well, we didn't take the 2 out yet.
Oh, you didn't?
No.
Oh, well now subtract 2.
No, it's
I'm sorry. I thought that was the final result. So there's a -2 here plus this. Sorry for the mess.
Oh, I added with the 2 and it's 185 over 24. So, right? I put a 2 in there because you guys didn't, right?
We didn't.
But the 2 can't go on the top of the fraction, can it? It has to go
Okay.
separate. It's 2 over 1 plus.
I want to get the base on here. And how do I get this computer to show this thing? I'm not sure what to do there with the sorry for the screen. I don't know how to kick that up right now. But I'm going to use -2. I'm adding to it the product of 11 and 17 divided by 24. And then I'll show you in another class session how to turn this into a fraction. And it turns out to be 139/24. 139/24. So sorry for that. And
48.
And the value of that is $5.79 approximately.
So it seems like it's much easier to do it after you do the billing.
Yeah, because you use the
Right.
5.79. Okay. So this is a 139/24 up there on the y-intercept. So the equation of the line then finally, sorry for trying to pack this in here, is the slope value is -11/24 x times x, and add to it the y-intercept 139 over 24. Yes?
So you would rather the exact as opposed to the
Yes, yes, the exact. Okay? And then you want to know, though, that 139/24 is about 5.79. So I suggest you write both down.
Because then it's easier to find it on the graph.
Yeah. Yeah, and you can find it on the graph depending on what scaling you put up there. This was a messy one because the numbers are not particularly clean. Now, these math books you have usually have very clean numbers in them, don't they? But what about the real world? If you're in business or science, chemistry, physics, biology, psychology, collecting data, are the numbers nice? No, usually not. So what we're doing is we use simple numbers oftentimes in these textbooks and in the examples and oftentimes in your homework so that you develop the ability to see the patterns, to see these patterns. And then you can then take that skill or knowledge and apply it to more complex things with maybe numbers that aren't quite as simple. Okay, so we took care of that. I only have 10 minutes left to cover the subject of circles, and I'll probably hold off on other issues about intercepts. I have time, though, to do one intercept thing with you, I think, with this problem. What's the other intercept that we'd be interested in? The x-intercept over here. And it better be somewhere less than 17, right? Okay, so let's look at that. I'm going to call it, why don't I call it A, letter A, and the y value there is going to have to be a 0, isn't it? Okay, so here's my equation right here. So how do we find that x-intercept?
Plug 0 in for y.
We let y equal 0. Okay. I want to save that other board over there for circles. So what I'm going to do is come back up here. And we're now looking for the x-intercept. There's some English. I'm going to let y equal 0 to find that thing. Okay, so I have an equation now that is 0 is equal to minus 11/24 times x plus this 139/24. What kind of an equation is this? What's it got in it?
Fractions.
Fractions. It's a fractional equation. You're going to hear me say that a lot this term. What kind of an equation is this? It's a fractional equation. What's the world's best way to clean up fractional equations? Get rid of the denominator by doing what? Multiply both sides of the equation by the common denominator of all the fractions you see. The common denominator here is real simple, 24. 24 times 0 stays 0. Now we have to distribute the product 24 times these terms. And so we lose the denominators, minus 11x plus 139. Everybody okay? Catch me if I make a mistake. Now what?
Subtract 139.
Now, what you normally would think of doing from your background is to kick the 139 over and then divide both sides by negative 11. A preferred way, we know we want x to be by itself, don't we? And notice that this term is negative. Why not kick it to the other side to make it positive by adding 11x to both sides? If you add 11x to both sides, we get a positive 11x over here equals this remaining value, 139 over here. At this point, if we multiply both sides by the reciprocal of 11, which is 1/11, doesn't that turn this left side into just x by using the reciprocal of the coefficient? Fancy vocabulary for something relatively simple here. 11 divided by 11 reduces to 1, so we end up with x equals 139/11. This is the a value. Yes?
In showing your work, when you went from 0 equals negative 11x to 139, you
Yes.
didn't actually show that you added a lot,
Right.
but then in the next step you did show the 111. Could you have gone from could you not have shown that and just gone to x equals 139 over 11? Or do you want
Certainly.
to see the
Yes.
111?
Yeah, I wanted to illustrate this idea though. When you have a term isolated with something in a coefficient in front of it. Now, where this technique is going to be useful is when this is a fraction. If this is a fraction, then you're going to multiply by both sides by the reciprocal. And that's going to make life simpler for you. Okay?
But in showing it, do you want which
No.
which of those two steps? You don't have to write, you can just keep going to the answers?
You go straight to this. Yeah. That's a real fundamental beginning algebra idea. I just wanted to show you this using the reciprocal as opposed to dividing both sides by 11. Okay. So anyway, we finally end up with the x-intercept as being this 139/11, comma 0. Notice how I highlight equations. I highlight these answers so that you can quickly look at the work with the picture and sort of see that it all fits together. Okay, we have less than 5 minutes left. I want to do the concept of circle with you so you can handle that homework over the weekend. Remember, at the beginning of class on Monday, I'll take questions. Okay, so here's the concept with a circle. Circle has points on it, doesn't it? Doesn't it have points? How many points are on this circle?
A whole lot.
A whole lot.
Infinity.
An infinite number of points. If you don't know something in math, you give it a symbol, like we said earlier. So why don't I just come out here and label this point what? What coordinates? X and Y, right? Now, the circle has a center. It's going to be tucked right in, right here, right? I don't know where that is exactly. In general, I'm going to call that H and K for the X value and the Y value. I'm down to 2 minutes. Okay. What's true about circles?
You go from the center to the side, and it's the radius.
This radius stays constant, doesn't it? That's what makes it a circle. From a fixed point, all points equidistant from a fixed point. All points equidistant from a fixed point gives us a circle. Okay, good old Pythagoras comes to our assistance again. So here we sit with a right triangle between the 2 points, the center and the general point on the circle. What's the rise between the points? Y minus K. Y minus K. Okay, what's the run between the 2 points?
X minus H.
X, here's X, folks. See it? X minus this H. So here we have a rise and a run. What's Pythagoras say about this relationship between the rise, the run, and the R?
Square, square, square.
X minus H, that leg squared, plus the other leg squared, equals the hypotenuse squared, which is the radius. Okay, should have another minute or so left. Okay, so now let me give you an example. What if this was x minus 5 quantity squared plus y plus 2 squared equals 6 squared? Where is the center? Be careful. You see the pattern, folks? The H value is 5. Be careful on that K value. What's the K?
Negative.
Negative 2, because a negative of a negative 2 becomes positive 2 there, okay? And the radius? 6. Real quick sketch. 5, negative 2. Here's your center. And the radius of 6 is going to be a little more than this x value. And so you draw the top, the bottom, the left, and the right, and we get our nice circle. Where we will pick up next class session is this thing has some x-intercepts, doesn't it? And it's also got some y-intercepts. So we'll take the same example and continue on with it next class session. Made it. Okay.